Hello, today we're going to look at a very classical problem about block sliding on an inclined surface. Some type of variation of this problem shows up in a lot of physics homeworks or exams. So let's get started by reading the question together. A block of mass 1 kg is placed on an inclined plane with a coefficient of friction of 0.3 and inclined angle of 37 degrees. A horizontal force 20 newtons is applied on the block. So we have to find in what direction will the block move, and using this information we have to show all the forces acting on the block. Afterwards we have to calculate the acceleration of the block. Well, let's get started by redrawing the ramp in a slightly magnified fashion and start identifying the forces that are acting on it. So what are the forces? Well, here are the forces, right? So you have force F, which is given as a 20 Newton force, which is pushing the block. We have the weight of the block down, and we have a normal force exerted on the block by a surface. So I'm gonna call the direction along the plane of this inclined surface to be my x direction, or x plane if you will. And the direction that's perpendicular to this I'm gonna call to be my y direction. Okay? Now, so what am I gonna do first? I'm gonna first identify the components of the forces that are not along this x or y lines. So there are two forces whose component who are not along x and y line. This is F and then W, and normal force is along y axis, so I don't have to worry about this. And you will see in a second why we need this. So we are given that this angle is 37. If this angle is 37, you can see that this angle is going to be 90 minus 37 because this is perpendicular to the flat surface here. So this is 90 minus 37, and since this angle is 90 degrees, this has to be 37 degrees. F is parallel to the flat surface here, and x component of this F is going to be parallel to the, well, inclined surface. So this angle must be 37. Why am I doing this? Well, because this allows me to break these forces into its components, and I can just look at the forces acting along the x direction and along the y direction. So what are the x components of F? Well, F sub x is going to be equal to F times cosine 37, because the 37 degree angle is the angle between the component and the force, right? So it's just essentially, if you think this as a hypotenuse and this is adjacent leg, the length of the adjacent leg is going to be just the hypotenuse times the angle, cosine of the angle between them, right? And Fy, you can move Fy here, and you see that Fy has to be opposite leg of the right triangle. So sine 37 equals to the opposite side, opposite leg divided by hypotenuse, which is F. So from here you get F sub y equals F sine 37. So we know F is 20 newtons, and cosine of 37 is 0.8, and sine of 37 is 0.6. So you get 16 newtons and 12 newtons for the x and y components respectively. We're going to do the same thing for y, but here note that this angle is 37. So W sub y is actually going to be W times cosine 37, and W sub x is going to be W times sine 37. So we know the weight of the block is its mass, which is 1 kilogram, times gravitational acceleration, which is 10 meters per second square. So 1 times 10 gives us 10 newtons. and we multiply them by corresponding sines and cosines of 37 degree. So we get for W sub x 6 newtons and W sub y 8 newtons. Okay, now comes the important point. So we note right away F sub x is bigger than W sub x, right? And along the x-axis there are only two forces. If F sub x is greater than W sub x, block will be moving along this direction, right? So this force dominates. So if block moves along this direction, then friction force has to be in the direction opposite to the direction of motion. And now we can draw a friction force, right? So now we completed drawing all the forces involved in the motion of this block. These forces are F, which is given, weight, which we know, normal force to the surface, and a friction force up in the direction opposite to the direction of the motion. Okay? Okay, so what we're gonna do, we're gonna ask ourselves a question. Is block moving along y direction? No, along the y direction, block is stationary. So normal force has to be equal to W sub y plus F sub y, right? These two forces have to add up to normal force because there is no motion along this y direction. Well, so if normal force is equals to W sub y plus F sub y, and we already calculated them, right? W sub y is 8 newtons and F sub y is 12 newtons. So normal force is 20 newtons. Now we can easily calculate a friction force because friction force is equals to coefficient of friction times normal force. So 0.3 times normal force, which we found to be 20 newtons, and friction force comes out to be 6 newtons. Well, if friction force is 6 newtons, now let's go back to our x-axis and identify the net forces here. So net force is going to be, because block is moving in this direction, Fx minus sum of these two forces, Wx and friction force, right? So net force, whatever this difference is going to give us a net force. So F sub x minus sum of W sub x plus friction force. Well, we know what F sub x is. We already found it here, 16 newtons. We know what the W sub x is, which is 6 newtons. And we know what the friction force is, which is also 6 newtons. So net force is 4 newtons. So there is 4 Newton force acting upward on the block, right? Net force of a 4 Newton acting upward on the block. Well, now what we're gonna do, we're gonna use the Newton's second law to find the acceleration. We know that net force has to be equal to the mass of the block times its acceleration. Or from here, acceleration is equals to net force divided by mass of the block. And we know the net force is 4 newtons, mass of the block is 1 kg, and acceleration of the block comes out to be 4 meters per second square. I hope this is clear to everyone and you guys learned something very useful today. Thank you for your time.